Hi, 8th graders. Yesterday you took a look at the Exploratory challenge, and I'm sure some of you found it very difficult. You should have. And then once you got going, it should have became easier and more obvious as what we wanted you to get out of this. Now, number 1 said to sketch the graph of the equation 9x plus 3y equals 18 using the intercepts. And then we're going to use that for A through F. So first thing you needed to do was make a little xy, and we're going to fill in our 0 so that we can find our x and y intercept. Reminder, when we fill in 0 for the x, 0 times anything is like we're covering that. So I'm going to leave my cursor there, and we're going to have 3y equals 18, divide by 3, y equals 6. We do the same thing, filling in 0 this time for the y. So we're going to 3 times 0 is 0, so it's gone. So 9x is 18, so x is 2. And then you would graph that. When you go to graph it, you're graphing 0, 6, and 2, 0, and then you would draw your line. Now, you had graph paper to do that on. You needed to use the graph paper. When we look at letter A, it says sketch the graph of the equation y equals negative 3x plus 6 on the same graph. So when you go to graph that, you are going to, because this is in slope-intercept, here's my slope, here's my y-intercept, I'm going to go up to 6, plot my point. I'm going to go down 3 over 1, right there, down 3 over 1, and you realize that it is on the exact same line. So you would draw that line, and there we go. We notice it's the same. What do you notice about it? What did I just say? What did we notice? Well, the two equations are the same. No, the two lines of the equations are the same, okay? So then it says we're going to rewrite y equals negative 3x plus 6 in standard form. Little reminder, standard form, ax plus by equals c. So we now have our negative 3x plus 6, and that was equal to y. Now, we need to make sure that we have our x's on the left-hand side. So we need to add 3x to both sides. And when I do that now, I have 3x plus y equals 6. Then part D says, identify the constants a, b, and c of the equation in standard form in part C. So we wrote it right here. So now I get to go and I'm going to say, well, what are they? A, B, and C. Well, here's my ax plus my b is that invisible 1, and c. So a is 3, b is 1, c is 6. Turn page. On the next, it says identify the constants in this equation. Now this equation was the very first one we graphed when we found the intercepts. So in this one, we're going to do the same thing. And we have our a is 9, our b is 3, and our c is 18. And letter F looks strange. Okay, oh sorry, these should be primes. Because we see all of those primes and then we have commas in here, so it kind of looks different. But we need to go ahead and fill in. So our A prime is 9. Our B prime was 3. And our C prime was 18. I got that from letter E. Now we have to go back and find A, B, and C. We've already done that. So when we look back, we can look right over here, and it's 3, 1, and 6. So I go ahead and I fill that in, 3, 1, and 6. Now I'm going to take a look at these. What is 9 over 3 the same as? Yeah, just 3. 3 over 1 is 3. And 18 over 6 is also 3. So we see that those equations were the same. This standard formula was actually just the whole thing multiplied by 3. Let's look at number 2. Sketch the graph of this using the y-intercept and the slope. Well, this is what it's called, right? Slope-intercept. So as you would graph it, again, you're on your graph paper. You're going to plot 0, 3, and then your slope is up 1 over 2, and draw your line. And then we're going to go on to letter A. It says sketch the graph of, and here's our standard form, using the intercepts. Again, in order to get our x and y intercepts, we use our xy chart, we fill in zeros. 0 for the x, so I'm covering up this over here. So now I have negative 8y equals negative 24. Well, what's going to happen when you divide by a negative? They're going to cancel, and 24 divided by 8 is 3. And now fill in 0 for the y. So we have 4x is negative 24. So x is negative 6. There's our ordered pairs right there. So now we're going to go ahead and graph that. We have 0, 3 and negative 6, 0. And hopefully you would notice then that it is, once again, the same line. That should have been a black line, sorry. Okay, so it should have been the same line. As we take a look at B, B says, what do you notice about them? Well, it is the exact same graph of the line, of the equations. The graphs of the two equations, are the same. Why? Why do you think that is? Yeah, one of them, the equation in standard form is multiples of the equation in slope-intercept form. All right. C says to write this equation in standard form. So again, standard form, ax plus by equals c. We need to get the x to the other side. We also need to worry about that fraction because we can't have a fraction in standard form. Remember that this a right here has to be positive and a whole number. So let's go ahead and I'm going to rewrite it over here. And to get rid of that denominator, let's multiply this whole thing by 2. That way we won't have any fractions. So 2 times y is 2y. 2 times 1/2 x is just 1x or x. And 2 times 3 is 6. Now it's almost in the correct form. What do I need to do? Yeah, we have x's over on the left side, so I need to subtract an x from both sides. And now I have negative x plus 2y equals 6. Now we can't have a negative here, so in order to do that, we're going to multiply everything by a negative, which is a -1 essentially. Same thing as just changing all of our signs. So we will have x minus 2y equals negative 6. Next problem, or next part. Identify the constants. Ready? Let's do A, B, and C. Our A, was, I already forgot, 1, and then negative 2 and negative 6. Then it says, identify the constants in our standard form. So A prime, B prime, and C prime. A is 4, B was 8, and C was negative 24. And let's find our comparison here. So A prime was negative 24 over A, which was 1. B prime was not negative, 8 over negative 2. And C prime, let's back up on that because I know you're thinking I'm crazy, and some days I am. Our A prime was 4 over 1, and then it was positive 8 over negative 2. And then C prime was negative 24 over negative 6. And I'm thinking, oh, this is a negative 8. All right, so, wow, that was rough on me, right? 4 divided by 1 is 4. Reduced it. Two negatives make a positive. 8 over 2 is still 4. Again, 2 negatives is a positive. And 24 divided by 6 is also 4. So they are a multiple of 4. Number 3, it says the graphs of the equations y equals 2/3 x minus 4 and 6x minus 9 is 36 are on the same line. Rewrite this one in standard form. Well, all we had to do, we didn't even have to worry about them being on the same. But if we write these in standard form, notice I'm going to take this whole thing before I begin and multiply it by 3. Now remember, why am I doing that? Yeah, I don't like this denominator of 3, so if I multiply by 3, it will always cancel. So now distribute your 3, and you'll have 3y equals 2x minus 12. And we need our x's over on the left, so I'm going to subtract 2x from both sides. I now have negative 2x plus 3y equals negative 12. And I can't have a negative at the beginning of my standard form, so I switch all the signs. So I just have 2x minus 3y equals 12. And then part B says identify the constant A, B, and C in the equation. So I'm going to go ahead and do that after, let's see, it's going to be 2, negative 3, and 12. 2, negative 3, and 12. There we go. So 2, negative 3, and 12. All right, and then it says identify the constants in the equation given. So here is our A prime, B prime, and C prime. And A is 6, B is negative 9, and C is 36. Again, we're going to go ahead and make some ratios of them. A prime was 6 over A, which is 2, reduces to 3. B prime is negative 9 over B, negative 3, which also reduces to 3. And finally, C prime, which is 36, over C, which is 12, reduces to 3. Now, you should have noticed that each fraction was equal to the same constant. Multiply that constant by the standard form of the equation from part A, and what do you notice? Okay, and we did that. Now, I want to show you, though, if you look at this right here, That's our constant, okay? So if we would multiply, that's what this is saying. If we use that, if we multiply each of the fractions, okay, multiply the constant by the standard form of the equation in part A. So let's look back at part A. And I need to scroll down a little bit. There we go. And if we multiplied everything by 3, that's what we would have gotten again. And that's what they're showing us. We multiplied by 3 in each one of those. Where we already did multiplied by 3, we wrote it in standard form. So we had 3y minus 3, no, that's not right. Yes. 3y minus 2x equals negative 12, right? Yeah. Yep, and then we were in the wrong order, so we had to switch those. So, we had 2x minus 3y equals 12. And now what they're saying is that 3 that we got as our constant, if we would have multiplied this whole equation by 3, 3 times 2x is 6x, 3 times negative 3y is negative 9y, and 3 times 12 is 36, which is what we got right here. Okay, so what it's showing you is you can multiply an equation by any number. As long as you're multiplying it by every single thing in the equation, they're equivalent equations. So as we take a look at number 4, where it says write 3 equations whose graph is this. Well, if this is the first one, all I have to do is multiply that by different numbers. So I can multiply it by 2 and get an answer, multiply it by 3 and get an answer, multiply it by 4 and get an answer. So 2 times 3x is 6x. 2 times 2y, 4y. And 2 times 7, 14. Another one, 3 times 3x is 9x. 3 times 2y is 6y. 3 times 7 is 21. And the last one, 4 times 3x is 12x. 4 times 2y is 8y. And 4 times 7 is 28. So if you notice, in this one, you can even see the pattern. Going up by 3s, going up by 2s, going up by 7s. Okay, you would do the same thing with number 6. Now number 7. And number 7, it says write at least 2 equations in the form of standard form whose graphs are shown. Now this one, we can't just look at this and see an equation because our y-intercept we can tell is not a whole number. Okay, so we have to find that. So what are we going to do? Well, first thing we can find is that slope, and that's going to be pretty easy. So let's go ahead and find 2 points and do our rise over run, and notice our slope is 1/4. Once we have that, we also have a point. So let's go ahead and use our point here is 3, 0, and we can use our point slope formula. So we have y minus y1, which in this case is 0, equals our slope, times x minus x1, which is 3. Let's go ahead and start solving. We get y equals, and then we get 1/4 of x, and then 1/4 of negative 3, which is negative 3/4. And then we're going to go ahead and move our x to the other side. Actually, before I do that, I think I'm going to go ahead and get rid of our fraction. And I have a 4. And we're going to go ahead and say 4y equals x minus 3. And now I'm going to go ahead and move that. So I'm going to do minus x from both sides. I have a negative x plus 4y equals to negative 3. And we know that we can't have a negative, so change all signs. So x plus 4y equals, x minus 4y. Minus 4y equals positive 3. So first one would be that. And then what can we do? Well, let's go ahead and multiply everything by 2. 2 times x is 2x. 2 times negative 4y is negative 8y. And 2 times 3 is 6. So that would be a second one. And that's 2. And number 8. Number 8 is going to be the same thing. We're going to have to find our y-intercept. So let's find our slope first. Here's a point, and here's a point. Our slope is down 1, 2, 3, 4. And a run of 1, 2, 3. So our slope is a negative 4/3, which, yes, if you look at it, it is nice negative. Pick an ordered pair, which we're going to use 2, negative 2. And we can go ahead and do y minus negative 2 equals negative 4/3 times x minus 2. So we now have y plus 2 equals negative 4/3 x plus 8 over 3. I just put that over 1 to make it easier. I'm going to go ahead and multiply every single thing times 3. So I now have I have 3y plus 6 equals negative 4x plus 8. I'm going to go ahead and subtract 6 from both sides. So I now have 3y equals negative 4x plus 2. I need to get my x's to the left side, so I add 4x to both. I now have, and I'm going to write it over because I'm running out of room, 4x plus 3y equals 2. And that's my first one. I can multiply it by anything. Let's multiply it by 4. 4 times 4 is 16x. 4 times 3y is 12y. And 4 times 2 is 8. So that is 2 equations. You could have chosen anything. You could have multiplied by 3. You could have multiplied by 6. Whatever. Good job, guys.